Right, for this next example, I wrote down a new system of equations, and remember in the last one we were able to just add the equations together and the y dropped out. Well, in this one, if I just add these equations together, there's no variable that's going to just drop out like we had last time, right? So the 2x and the minus x, if I add them I get x. And the y and the 3y, if I add them, I get 4y. And so I don't get anything with a 0. And so it seems as though we're at a standstill. However, there is a solution. There is a way to fix that. I talked about in the last video the idea of the multiplication principle of equality. The fact that I can multiply both sides of an equation by anything I want. The equation's still true and the solutions are still the same. And so I'm going to pick a number. Basically the strategy here is I want to get the coefficients to be opposites of each other so that when I add them together they'll drop out. I could get both of the y's to have opposites, like a -3 and a +3. Or I could get both the x's to be opposites, like a +2 and a -2. I'm going to choose the x's here because one's already positive and one's already negative, so that when I add them together I want them to zero out. And so I need a 2 here, a -2 instead of a -1. To do that I'm going to multiply this second equation by 2 on both sides. Okay, so I'm going to take this equation and I'm going to draw it this way. I'm going to multiply it by 2, and that's going to give me a -2x plus 6y equals -12. And so all I did was multiply both sides of the equation by 2, which is a valid thing to do with equations. The other equation I'm going to leave fixed. I'm going to leave it alone, and I'm going to have 2x plus y equals 5, and we're going to add those together. Okay, the x's will add up to 0x, the y's will add up to 7y, and the constants will add up to a -7. Okay. The x's drop out. I get 7y is equal to -7. I can divide both sides by 7, and I get a y value of -1. However, remember, we're not done. We still need to find the ordered pair for our solution. We need the x value. So I take that -1 and I can plug it in again to either of the first two equations. I'll choose the top one. I just think the numbers will work out nicely there. So I go with 2x plus, now the y value becomes -1, equals 5. I'm going to add a 1 to both sides. That will zero out the 1 on the left. 2x is equal to 6, and when I divide out the 2, I'm left with x equal to 3. Okay, so now I have both the x and y values, and of course my final answer needs to be in ordered pair form. So I have 3 common -1 as my ordered pair. I'm going to quick double check and make sure that works, just mentally here. If I take the 3 and plug it in for x and the -1 for y, 3 and -1, I get 3 times 2 is 6. 6 plus -1 will be 5, so that works out correctly. If I put the 3 in here, I get -3. If I put the -1 in here, I also get a -3. Right? -1 times 3. So I get -3 plus -3, which also gives me -6. Alright, so it works in both equations.